Assalamu alaikum. Today I'm going to explain turning forces in simple machines. Let's start. First of all, we have to know that we have three different machines. We have levers, ramp, and pulleys. Let's start with levers. What is a lever? Lever is a simple machine which consists of long bar pivoted or rotate around a fixed point. This fixed point is known as fulcrum or pivot. We can use lever to raise a load. So we apply a force here and we are trying to raise the load here. The distance between the effort and the pivot, this distance is known as effort distance, while the distance between the load and the pivot is known as load distance. Levers may be force multiplier or distance multiplier. How to differentiate between them? If you find the effort distance longer than the load distance، لو لقينا يا ولاد ال effort distance longer than the load distance يبقى this type of lever is force multiplier. And vice versa. يعني لو لقينا ال load distance longer than effort distance, this means that this type of lever is distance multiplier. Okay, so lever can be force multiplier if the effort distance is longer than the load distance. Okay. For distance multiplier, here is a pivot, and here is a load, and here is your effort. So here the distance from the pivot to the fulcrum is shorter than from the load to the fulcrum. So this type of lever is distance multiplier. The difference between force multiplier and distance multiplier depending on the length of effort distance and load distance. لو effort distance بتاعتي greater than load distance يبقى this type of lever هنسميه force multiplier. اوكي، لكن لو كان العكس، لو كان اللود distance بتاعتي greater than effort distance يبقى this type of lever is distance multiplier. Okay, then let's see some examples to differentiate between force multiplier and distance multiplier. Here we have a bottle opener. In the bottle opener, we pivoted on this point. So this point is the fulcrum or the pivot. We apply our effort here or our force here. So this is the effort. And we wish to raise this point up, or the load. Here is the load. So as you see here, the load distance is shorter than the effort distance. So we can consider that bottle opener is a force multiplier. Let's see this arm. Here is the pivot, and here is the load, and here is the effort. So to measure the distance between the effort and the fulcrum and the load and the fulcrum, which one is longer? It's clear in the load distance greater than effort distance. That's why the arm acts as distance multiplier. Here we have some levers. Let's classify them into distance multiplier or force multiplier. First example is scissors. Here is a pivot, and we apply the effort here. So the distance from here to here is the effort distance, and we place the load here in this position, not here. We apply the load here. So the distance from here to here is shorter. Okay, so here we have scissors is a force multiplier. Why? Because the effort distance longer than load distance. Look at the hammer claw. It is pivoted in this point, and the nail is in that point. So the distance between the nail and the load is very short, while the arm or your hand is placed here. So the distance, the effort arm is longer than the load arm. So this is the effort arm, and here the short distance is the load arm. So we can consider hammer claw as a force multiplier. For a crowbar, it's very clear. Here is the load distance, and from here to here is the effort distance. So effort distance is greater. So this crowbar is a force multiplier. For a nail clipper, here is the pivot. we apply our effort here, and we place the load here, and here is the pivot or the fulcrum. So the distance from here to here is longer than from here to here. So we can consider nail clipper as force multiplier. The same in pincers and suction pump. Here, this is the manual broom. In manual broom, you hold the manual from this point. This is a fixed point, and you push from this position. This is the effort. And the load is placed here. Okay, look here, distance from fulcrum to effort is shorter than fulcrum to load. So load distance is longer, so manual broom is distance multiplier. The same for tweezer. Here, this is a fixed point with the fulcrum or the pivot, and here we apply the effort, and here is the load. So as you see here, the effort distance is less than the load distance, so tweezers are force multiplier. The same for hockey pad and fashing tool. This is a pivot, and you apply your effort here, and the load is here. So the distance from the fulcrum to the effort is shorter than from fulcrum to the load. So fashing tool is considered as distance multiplier. Now we are going to explain moment, what is meant by moment. If we have a rod or beam, and this beam is pivoted at a fulcrum or pivot like this, okay, and here we apply a force here. If this force succeeded to turn the beam, we can say that this force has moment. لو الفورس دي قدرت تعمل turning تلف في البيم بتاعي، يبقى الفورس دي ليها moment، هي عملت rotation. Okay, how can we calculate the moment of a force? The moment of a force equal to the force multiply the distance from the force to the pivot, this distance. Okay, so the definition of the moment, it is a turning effect of a force. The formula of moment, force times perpendicular distance. And here this means that the force and the distance should be perpendicular، يعني الانجل ما بينهم 90 degree. هشرحها لكم مرة تانية هنا عشان نشوف بس الرسمة تبقى واضحة. What we have here, this is the distance, and there is a force. The angle between the force and the distance is 90 degrees. This is what's meant by perpendicular distance. The measuring unit for moment, it is the unit of force, which is Newton, times the unit of distance, which is maybe meter or centimeter. لو كانت سنتيمتر يبقى نيوتن سنتيمتر، أما لو كانت متر يبقى نيوتن متر. These are the units for moment, Newton meter or Newton centimeter. Okay. Moment has direction. This means that يعني this is a beam، لو ده البيم بتاعي وهنا كده البيفوت كده. Okay, and we apply a force downward like that. So this force tends to return the beam in this direction, and this direction is opposite to the direction of clockwise. We say this direction is anti-clockwise direction. So this moment called anti-clockwise moment. But if we apply another force here, so the beam will rotate in the opposite direction like that. So this will be clockwise moment. So we have two directions for moments, clockwise or anti-clockwise. Here's some declaration for the direction of clockwise and here direction of anti-clockwise. If the clockwise moment equal the anti-clockwise moment, we can say that this beam or this rod is balanced or at equilibrium. Equilibrium معناها في حالة اتزان، يعني it will not rotate، هي مش هتعمل turning، مش هتلف. ليه؟ عشان ال clockwise moment equal to the anti-clockwise moment. Okay, let's see examples for moment. A spanner is used to undo a nut. A force of 20 Newton is applied 0.2 meter from the nut. Calculate the moment of the force. Moment equal force times perpendicular distance. So the force here is 20 times perpendicular distance, which is 0.2. So we got here 4 Newton meter. So the moment is 4, the unit is Newton meter. Here the diagram shows a lever being used to lift a heavy box. Calculate the moment of the load about the pivot. Here of the load applies force of 500 and distance from the load to the pivot is 0.5. So the moment here is 500 times 0.5. So we get here 250 Newton meter. So the moment is 250 and the unit is Newton meter. Calculate the moment of the effort about the pivot. So we have here the effort of 200 Newton and the distance of effort is 1.5. So what is the moment of the effort? So it's force times distance here, which is 200 times 1.5. We get 300 Newton meter, okay? Here we should know that the moment by the effort is greater than the moment of the load. So this beam will rotate in the direction of this direction. عشان هنا الeffort بتاعنا هيعمل moment greater than the moment of the load. يعني clockwise moment هيكون greater than anti-clockwise moment. فعشان كده this beam will not be balanced. مش هيبقى فيه balance لأن let's start the work done. If we have a person, as this person is pushing the box to the right, so he applies a force F to the right, and the box move in the same direction, move distance D. So the work done equal the applied force multiplies the distance moved. وهنا في condition يعني لازم تكون the distance والforce both are in the same direction. So we can say that work done equal force times distance in the same direction of force. In the same direction of force. The unit for measuring work done is joule because work done is energy transfer. فالwork done نقدر نعتبره كenergy that's why the unit is joule. Let's have an example. A force of 200 Newton is done to push an object 3 meter. أنا عندي هنا الobject ده 200 Newton. We are pushing this object up فعملنا force 200 meter. What is the work done in this case? So the work done equal force times distance. So it is 200 times 3. It is 600 joule. Okay. Then let's go to another sample machine, which is ramp. Ramp is a sample machine that needs less force to push an object up a slope. If we need to lift this object upward, we have to apply a force of 1000 Newton, and the object traveled from here to here, it's 2 meters. So the work done in this case will be 1000 times 2 will be 2000 joule. Okay, لكن الفورس اللي applied by person هنا it must be 1000 Newton. طيب ايه بقى الفايدة من ان انا instead of lifting the object directly up ان انا pushing the object up a slope اللي هو الرامب بتاعي. لما استخدم الرامب we use less force لكن بنمشي longer distance. يعني هنا the same person is pushing the box, he applies 500 Newton, لكن distance moved is the length of this ramp is 4 meters. Just if you think a moment, you will find that the work done by this person in this case will be the force times the distance. الفورس اللي عملها اللي هي في الدايركشن دوت times the distance اللي هي في نفس الدايركشن بتاع الفورس. So it will be 500 times 4 equal 2000 joule. يبقى ال work done here directly upward or across a slope is the same. لكن the difference here we use greater force but shorter distance. But here we use less force لكن longer distance. Let's have some questions about ramp. For this example here, this object has weight of 1000 Newton. Where is it? Directly up 3 meters. So the work done here is 3 times 1000 is 3000 joule. What is the force? Let's consider this force is unknown. What is the force required to push the object up the ramp of length 5 meter؟ طبعا احنا لازم نكون عارفين ان انت عند البوزيشن دوت الورك done the same سواء ان انت اتحركت من هنا لهنا او من هنا لهنا. فلو كان الورك done من هنا لهنا equal 1000 times 3 فالورك done من هنا هيبقى force which is unknown times 5. يعني خليني أقول لك الforce times 5 equal from the other side 1000 times 3. يعني F times 5 equal 3000. So F equal 3000 divided by 5, we get 600 Newton. So the applied force here is 600 Newton. So as you see, لو انت حاولت ترفع الاوبجكت ده directly up هتعمل فورس قد ايه؟ 1000 نيوتن. بس انت لو عملته across ramp هتعمل فورس قد ايه؟ 600 only. But it will travel longer distance. Why? Because at the end, two ways دول هيgive the object the same work done. Finally, they will get the same work done. Now the last point is pulleys. Pulleys are force multiplier. Okay, لكن في كيس واحدة بس من البوليز which is not force multiplier. تعالوا نشوف هنا كده. This is a load. This load is 100 Newton. Okay, so to raise this object up احنا محتاجين نعمل force equal to 100 Newton. فانت هتيجي تشد الحبل ده من هنا تعمل فورس قد ايه؟ 100 نيوتن. فتخيل انت لو عايز ترفع اللود بتاعك 1 متر up، يعني from here to here 1 meter. This requires ان انت تشد الحبل بتاعك ده كده 1 meter. Okay, so this type or this system does not save any effort, or it is not a force multiplier because you applied 100 Newton and you raise up 100 Newton. In the second system, here, this is a load 100 Newton. This 100 Newton is divided along two ropes. So this is 50 Newton and this is 50 Newton. So to raise this one, do you see? Do you imagine this rope like this? عشان تقدر ترفع ده كده ال 50 نيوتن لازم تعمل force equal to 50 نيوتن. طب لو if you want to raise the object 1 meter up، عشان يطلع 1 meter up لازم يطلع 1 meter from this part and 1 meter from this part. 1 meter here and 1 meter here, and this required that you pull the rope in this direction 2 meter. يبقى انت هنا عشان ترفع هنا 1 meter عملت هنا ايه؟ distance 2 meter. انت applied هنا force اقل ولكن longer distance. عكس الكيس هنا عملت 1 meter و 100 نيوتن. هنا عملت half الفورس ودبل الديستنس. لو بصينا للكيس التالتة عندك 100 نيوتن وعندك هنا 4 ropes 1 2 3 4. فال 100 نيوتن هتديفايد على ال 4 ropes، كل حبل من دول هيبقى فيه 25 نيوتن. Okay, when you want to push or raise the object up, you have to apply a force of 25 نيوتن. لو هترفع الروب ده كده 1 meter up، كل ده هيطلع 1 meter، فانت عندك 1 meter هنا 1 meter هنا 1 meter من هنا 1 meter من هنا، يبقى you have to pull this rope down 4 meter. يبقى انت عملت less force ولكن longer distance. ليه؟ عشان finally it must have the same work done. نفس الwork done. فلو الفورس بتاعتك قلت الديستنس لازم تزيد، لأن الwork done equal force times distance. So now you see that pulleys are force multiplier, except in that case if we have only one rope, one pulley, it does not save any effort. ما بتوفرليش أي effort، فبالتالي في الكيس دي it is not a force multiplier. Like in here and here are force multiplier. This is not force multiplier. Not force multiplier. For this case only. But this and that consider as force multiplier. Okay, and here generally we can consider pulley as a force multiplier. Here we have two pulleys can be used to lift a load. عندك two pulleys A and B. Are the pulleys acting as force multiplier or distance multiplier? It will act as force multiplier. Which set of pulleys will need the smallest force on the rope to lift a weight? طبعا it's clear in system B هيبقى هو دوت smallest force، عشان عندي هنا this is 60 Newton. So the 60 Newton will divide into 4 ropes، يعني كل حبل من دول هيبقى 15 وده كمان هيبقى نيوتن، وهنا هيبقى فيه 15 نيوتن، هنا 15 نيوتن، هنا كمان 15 نيوتن. So which one هيبقى B? Which pulley the rope will have to be pulled the farthest to lift 1 meter? The farthest to lift هيبقى طبعا أنا عملت فيها less force. يعني دي مثلا 60 هنا 30 نيوتن، هنا 30 نيوتن، فاحنا هنا هنعمل apply force down to be 30 نيوتن. لكن هنعمل force قد ايه؟ 15 نيوتن. The smaller the force, the longer the distance move. B. Explain your answer. The smaller the force, the longer the distance. Because work done in two cases is the same. Because work done is the same. Here I have another question. The diagram shows a block being lifted in two different ways. The man does work when he moves a box. Write down two more examples of where ramps are used. Where we can use ramp, we can use ramp in front of building, for wheelchair. Recommend in lifting or loading, in loading ships or lures. Okay. The work done equal force times distance moved in the same direction of the force. Calculate the work done by the block directly upward. Directly upward across this line. So the force here is 1000 times 2 equal to 1000 joule. Calculate the work done to push the block up the ramp. So we have here 500 times 4, we get 2000 joule. So the work done will be 2000 joule. As I told you, the work done from here is the same as here because the same object and the same height. أتمنى أكون فهمنا الدرس دوت وأشوفكم على خير إن شاء الله. السلام عليكم.